Okay, good afternoon. We are from class of AE4000. My name is M Ahdal'ula Rayhanfasya, student number 136160009, with two other members of this team, Hasna Afifa, student number 1361607, and Ilham Aris Hartadi, student number 1361643. Today we are presenting about the ocean cleanup aerial expedition for today's task of AE4000. First of all, what is the Ocean Cleanup? The Ocean Cleanup is a non-profit organization is developing advanced technologies to rid the world's oceans of plastic. It is invented by Dutch inventor Boyan Slat, founded at the age of 18 in 2013 in his hometown of Delft, Netherlands. This is the aircraft used in the Ocean Cleanup mission, C-130 Hercules aircraft with sensors on board. The aerial expedition itself is the world-renowned aerial expedition was an ocean cleanup mission that involved a string of aviation surveys and exploration around the Great Pacific Garbage Patch. It is located between Hawaii and west coast of America. The operation started in 26th of September back in 2016 and lasted 11 days with the goal of finding exactly how much of the ocean's largest and most dangerous waste, unused fishing equipment known as ghost nets, are present in the area. This is the example of the debris floating around the Great Pacific Garbage Patch. How? How the mission is accomplished is by using this C-130 Hercules aircraft. 10 researchers, 3 sensor technicians, and 7 navigational crew man the colossal C-130 Hercules aircraft, named Ocean Force One, that glided close to the ocean at speeds of 140 knots at an altitude of 400 meters. State-of-the-art sensors made an accurate estimate of the size and weight of the objects that were detected from above. So this aircraft is equipped with many sensors that can take aerial imagery and artificially intelligent system that can locate and track the debris and how much the debris and estimating its weight. Then that data will be analyzed in the post-processing process and will be presented as a paper to show people that there are a lot of trash in the Great Pacific Garbage Patch. This is the example of the result. This is bundle net, the stray net or ghost nets. This is the one of the most dangerous thing floating around the ocean because it can snake around ship propellers, also trap sea creatures like fish or whales or other animals. This is loose net. Loose net is similar like bundle net, but nothing is trapped and it's just floating around and it's larger in dimension. Rope is rope may be thrown away by a large ship container from ship. Maybe it fell and contaminating the water. Unknown objects and also buoy. Buoy is like a marker and floating around. Not every buoy is a trash, but stray buoys can be a danger for cruising ships around that area.
So this is the recovery of the project. It is approximately 80,000 tons of plastic of varying form and size, primarily polyethylene and polypropylene based, are amassed in a patch of ocean that cover an estimated surface area of 1.6 million square kilometers. That is roughly twice the size of Texas or 3 times the size of France. Extremely high percent of microplastic, which account for the most of calculated 1.8 trillion pieces of debris floating in the Great Pacific Garbage Patch. It's equivalent to 250 pieces of debris for every human in the world. The accumulated trash continued to grow at an exponential rate since it was first discovered in the 70s. The aerial expedition also discovered that more than 90% of the buildup is composed of debris that is bigger than 5 millimeters. This is the recorded data of location and route of the GPS tracker that were installed on all participating vessels that consists of a fleet of 30 boats, 652 surface net, and 2 flights. The upper image is the model mass concentration, while the lower is measured concentration model by the size of the debris. The model shows how the concentration level gradually decreased by order of magnitude toward the outside boundaries. The center concentration level contained the highest density, reaching hundreds of kg per square kilometer, while decreasing down to 10 kg per square kilometer in the outermost region. This graphic shows that the plastic mass concentration is increasing exponentially from the 70s, proving that the input of plastic in the patch is greater than the output. And the observed characteristic of the debris in this garbage patch, such as plastic tape and age, prove that plastic has the capacity to persist in this region. So what's next? We can clean up the garbage patch using conventional method with vessel and nets that will take thousands of years and tens of billions of dollars to complete. Or we use the ocean cleanup passive system that are estimated to remove half on the Great Pacific garbage patch in just 5 years and at a fraction of the cost. It's not an ice, by the way.
Now, I'm gonna continue about the explanation that my friends already talked about. The things that I wanna explain is the cleaning method. First, create a coastline where there are none. The challenge of cleaning up the gyres is that plastic pollution is spread across millions of square kilometers and travels in all directions. Ocean cleanup technology has been designed to do the hard job of concentrating the plastic first before it can be effectively removed from the ocean. The system consists of a long floater that sits at the surface of the water and skirt that hangs beneath it. The floor provides buoyancy to the entire system, while the skirt prevents debris from escaping underneath and leads it into the retention system or code end. A cork line above the skirt prevents overtopping and keeps the skirt afloat. And the second one is take advantage of natural oceanic forces. For an area of this size, active cleanup methods will be too energy intensive. This is why a passive design was chosen. The cleanup system relies on natural forces to navigate the patches, a feature that also increases its survivability in the harsh ocean environment. Both the plastic and system are being carried by the wind, waves, and current. However, to catch plastics, there needs to be a difference in speed between the system and the plastics. Using a sea anchor to slow down the system, plastic can be retained and captured. And last, concentrate the plastic and take it out. How to do it? To capture, accumulation, and then extraction. And last topic is impact. Models show that a full-scale cleanup system rollout could clean 50% of the Great Pacific garbage path patch in just 5 years. After fleets of systems are deployed into every ocean gyre, combined with source reduction, the ocean cleanup projects to be able to remove 90% of ocean plastics by 2040. And thank you. That's all from our group from this presentation.